This is Doug, and in this video we're looking at exponential functions and the natural log. So first of all, it's important to know what e actually is, as e is a thing that we will be working with today. And e is just a number. It's a little bit like pi in the way that it's a number which is never ending, but it is 2.71828 and then carries on and on and on. But the most important thing about e to learn is the fact that it always has a gradient of e to the x. So y to the e to the x, if you differentiate that to try and find the gradient, you just get e to the x. Now, it goes slightly different when you have a constant before the x, as y to the e to the kx would differentiate to give k times by e to the kx. But we'll learn more about that when we start looking at things like the tangents and everything, which we'll look at in the second half of this video. But the next thing we need to know is about the natural log, and we'll start using in these two questions here a little bit about the natural log. And y equals e to the x is the inverse of that is y equals log base e to the x. Now that can be simplified written as y is equal to ln x. So if you start looking at some questions here of how we can use this inverse in order to find out what x is. And the first one here is saying that e to the 5 minus x is equal to 100. And I will always use the idea of doing left, right, middle. So I say that this one's left here, this one is right, and then the power is middle. And that's how I work it out. If you're using it in this, this form, you have to make sure you write it in this form. And then you do log left, so log and then to the base of left, so that means that log to the base e of 100 is equal to the power, so is equal to 5 minus x. If you put that into your calculator, then that could be written as ln 100 instead of log e base e to the 100, but I've written it as that for now. And if you put that into your calculator, you get 4.605 is equal to 5 minus x. So therefore, if you do a bit of rearranging, you end up getting 5 minus 4.605. So x is equal to 0.395. So the next one here has just the same premise, but it is just slightly different in the terms that now we're working luns at the start. It's just basically the opposite way around. And again, we're going to be using that left, right, middle technique. But as we can see, it doesn't look like there is a base on this one, but this is where you can just use the other form, so the log e to the x, as that is exactly the same as ln to the x. So therefore, the left is going to be e. The right will be 2, so it's going to be e squared is equal to 18x minus 55. Then e squared plus 55 is equal to 62.389. And that's equal to 18x, which means that x is equal to 3.466. So these are a couple of questions looking at things like tangents and normals and looking more at the idea of how to differentiate e. So the first one says that find the equation of the tangent to the curve y equals e to the power of minus x at the point 2e to the power of minus 2. So the first thing to say is that we need to know that this here is x, so x is equal to 2, and y is equal to e to the minus 2. And then the next thing to do is to find what dy by dx is, so if we're differentiating this. Now, as we saw in a previous first half of this video, you'll put the minus at the front, because you can say that k, for example, if you're saying this is k would be minus 1. So you're basically timesing the start by minus 1, and then it would stay the same, so you can have minus e to the minus x. So that is that differentiated, and then you can start putting the y's and the x's back in. Because if you were to write this out in the formula, then you'd have y is equal to minus e to the minus, and then we'll put the 2 here, because we know that's 2, and then afterwards you always put an x, and then plus c. Now we'll sub back in the x's and the y's. So the y is equal to e to the minus 2 is equal to minus e to the minus 2, and that's times by 2 plus c. And therefore, if you use a calculator to work out what everything is, so for example, you know that e to the minus 2 is equal to 0.135, then you can work out that c is equal to 0.406. So therefore, y is equal to minus e to the minus 2x plus 0.406. And it's also worth mentioning that this 0.406 could also be written as 3e to the minus 2, as you're basically moving that over. So that is where we've got this 0.406 from. So the next one is looking more at the normal of a curve instead of a tangent. So that means that we're going to have to take the negative reciprocal at some point. And if you don't know about that, look at the video looking at normals and tangents and differentiation. So this time we actually need to work out, we don't get x and y directly given to us, we get x given to us. So we know that x is equal to 1. But then y, in order to do that, we're just going to sub 1 into the y, so y is equal to e then to the minus 2, so then y is equal to 0.135. Again, we're going to differentiate now, so dy by dx is going to be equal, so then we know here that k is equal to minus 2, so we'll put the minus 2 to the front, then we'll have the e, and then we'll have minus 2x. But as that is the tangent gradient, and we need the normal gradient, just put the m for that. M can be gradient, so that's the normal gradient would be equal to 1 over, and then you'll take away the minus because it's a negative reciprocal, so that would be 2e to the minus 2x. So therefore, if we're summing it back now and we put back into the y's and the x's, then we have 0.135 is equal, now sub that into your calculator, 1 over 2e to the minus 2x, and you'll find that you get 3.695. And this is times by 1, so you don't need to do anything with that, plus c. So again, then do 0.135 minus 3.695, and you can find out that c is equal to minus 3.559. So now that we have that, we can just sub it back into the final equation. So y is equal to 3.695 x minus 3.559. That's the final equation. So two similar questions, just looking at the normal and the tangent. The most important thing to know is just how to differentiate. So when it has e in it, so obviously if it's y to e to the x, then you're just going to go to y is equal to e to the x. Nothing changes. But when there's a constant in it, then slightly different changes happen, as we've seen here. So thanks for watching this video, and see you soon. Bye.